Alright, so one on this one, SQ bisects RQT and RQ angle RQS. The reason is for that is what now? Given information, yes, given. Alright, then on the next line. The statement is missing, but the reason is definition of an angle bisector. See if anybody can figure this out without me skipping to the next line. Definition of an angle bisector. That's the reason. Why would they say that right there? What are they asking you to write on it as a statement? I think y'all gonna struggle with this one, so let me see what you say. No. That's way too unspecific. Let's go to the next line then. We'll come back to line 2. The next line, the statement says angle RSQ is congruent to angle TSQ. See if you can find those two angles for yourself first. RSQ. Find that angle. They said that's congruent to TSQ. That is true. We even marked it. If you know what you're looking for. Why did we mark that though? Like, what's the reason for that? You got to give me an actual reason. Don't make nothing up. The reasons are over here on the reference sheet. Thank you. Definition of an angle bisector. Let me show y'all those angles. I know some of y'all don't see. Y'all probably staring at the paper. Read the angle. The middle letter is where the angle actually is. RSQ. The small angle that we mark right here is RSQ. And then TSQ. The one on the bottom is the one that we marked TSQ. Pay attention, one. These two angles right here we marked because they told us SQ was a bisector. If that's the case, the reason we know those angles are congruent, this is definition of an angle bisector. Look at your reason chart. Keep using it, man. There's only so many reasons we're going to have for angles to be congruent. Pick the one that makes sense for your situation. Definition of angle bisector. So now that we answer line 3, I go back up. Let's try line 2 again. Line 2, the reason is definition of an angle bisector. The same thing we got on line 3. What's missing in our statement on line 2? I want somebody else besides Amani. I feel like she's the only one that's working with me right now. Aiden, let's go. I agree with RQS. But what are you naming the other angle? No. You're saying the same thing. You don't even mention anything. Thank you, Reese. You got to name them both the same way, but you called the first one RQS. Angle TQS. You follow me, Aiden? You named the first one RQS, which is correct. So the second we have to name TQS. Go the same direction. No, it has to be the two that are bisected by SQ. We already named the other two bisected ones. These on line 3. These are the two that were created by the bisection of SQ. Here and here. You need to name those angles. Juan, you're getting too distracted, bro, man. I really need you to focus, man. You keep talking to Chris and let's go. Part 4 statement is missing. The reason is reflexive property. Y'all should be able to get this right by now. Faith. What you writing on for? Yes, Faith. No. I know you know why. I need somebody else to know why. Aiden, what's up? No. Go ahead, Imani. Tell them why what they said was wrong. Yes. This is not a rotation of an image, this is a reflection. Has to be QS is congruent to QS. Or if you want to say SQ is congruent to SQ, but you cannot mix. Last line, triangle QRS is congruent to triangle QST. We've marked the only thing we didn't do, I'm sorry, and I skipped it. We didn't mark QS congruent to QS. We should have done that. Mark QS congruent to QS. Now I can go to my last line. Triangle QRS is congruent to triangle QTS. Go ahead, Ms. Johnson. Yes, sir. Angle, side. If two angles in a non-included side of one triangle are congruent to two angles in a non-included side of another triangle, then the triangles are congruent. Angle A is congruent. This is just your notes too, Reese. Don't get overexcited. I got another one coming to you after this. Angle B is congruent to angle E. Then after that, side BC is congruent to side EF. If that's the case, in triangle ABC is congruent to triangle DEF. This is by angle side congruence. At the bottom, just a little quick note, non-included means the side opposite of the angles. Last page. Sample AAS proof. YZ bisects angle WYX. Let me say that correctly. YZ bisects angle WYX. So YZ is a segment, goes through and bisects that angle. We need to mark that we understand that angle is being bisected. WYX is the big angle across the top here. If that's the case, YZ, the segment comes in and bisects it, cuts it in half here and here. Bisects the angle. The two small angles are congruent. We mark that because we know that. That's what they just told us. Then after that, they say angle YWZ is congruent to angle YXZ. They're just telling us that information. We need to mark it though. YWZ, middle letter is where the angle actually is. We need to mark that angle congruent to YXZ. This angle. Mark the angles congruent, please. What's up? Okay. And then after that, we want to prove the triangles are congruent. WYZ, XYZ. So part number one statement is YZ bisects angle WYX. What's the reason? Given. This is a good one to see too, because you need to understand. You won't always write all the given information on the first couple of lines. Sometimes it'll be mixed in. If you look, our next line is not given information. It's something we're going to determine for ourselves. But since the next line is something we're going to determine for ourselves, I guarantee it's based off something that you've already been given. Next line says definition of angle bisector. Somebody besides Imani, impress me. Or Aiden. Or Vincent. Faith, you got your hand up? Alright, go ahead. Good. She said angle WYZ is congruent to angle XYZ. This is correct. This is the definition of angle bisector, because those are two small angles that we mark based off knowing that YZ is bisector of YWX. It creates two small angles for us, WYZ, this one we marked here, and XYZ, the one that we marked here. So that's definition of an angle bisector for us. Next line is given, so Reese wants to answer that. What's the other piece of given information, Reese?
I think it's angle YWZ. Angle YXZ.
Yes. We already marked that, so we good. And then the next line says YZ is congruent to YZ. Sophia, why is that? Reflexive property. We need to mark that too. YZ congruent to YZ. Once you mark your proof correctly, it's easy for you to read. The last line is triangle congruent to the triangle. And you obviously know why the triangles are congruent. Angle, angle, side congruency. This is you proving that. One thing I will say with the proofs, well, I'll say it after this one. Let me do this next one first. The last one, right triangle congruency using HL. So remember, HL can only be used on right triangles. Says if the hypotenuse and the leg of one triangle is congruent to the hypotenuse and the leg of another triangle, then the triangles are congruent. They have to be right triangles though. So it says if, and this is hypotenuse out to the side, so BC is congruent to EF. And the leg, in this case they got AB congruent to DE. Then triangle ABC is congruent to triangle DEF by hypotenuse leg theorem. The hypotenuse is the side opposite of a right angle. If you didn't know, the leg is one of the sides adjacent to the right angle. Then from there, HL. So on this one, MP, what's that symbol mean? Perpendicular. MP is perpendicular to LN. They already indicated that on figure 4. So how did they indicate that? How we know those are perpendicular, MP and LN? That right angle right there. Anytime you got a right angle, you have to have perpendicular lines. What you can do, you can add the right angle on the other side if it makes you feel better. Just know that both of those are right angles. Then after that, it said, they said ML is congruent to MN. We need to mark that on our figure. Segment ML is congruent to segment MN. So that's our given information on this one. Now we need to work our way through the proof. Starting out, MP is perpendicular to LN. Go ahead, Reese. Then after that, it says angle MPL is congruent to angle MPN. No, I ain't say that. I'm reading that wrong. Angle MPN and MPL and angle MPN are right angles. I'm sorry, they didn't say they're congruent, even though they are congruent. They just said they're right angles. How do they know they're right angles? It must have been something that told them that. Yeah. No, sir. Let's see. I'm interested to see what you say. Nah. Miss Johnson. Shh, a little bit louder. Definition of perpendicular lines. What's the first thing they mentioned to us? What's the first statement they gave us? MP was perpendicular to LN. Your next statement is if they're gonna say that and they're gonna tell you about right angles, then make sense of it. Why do you know those are right angles? Their definition of perpendicular lines. A proof should make sense. Did I tell you? You're not ready. Don't ask me no questions. You want the next one, Reese? Go ahead. Reflexive property is the reason. Go ahead. MP is congruent to MP. The next line is given. I know it feels weird to you, but on this one, if you see, we don't even mention our next given until the fourth line, which is fine. Givens don't always go in order. They're not even always like in the order that they're written. It's based on what you see in the proof. What's up?
Side ML is congruent to side MN.
Yes. And we need to mark that. Oh, we already marked that. Only thing we did mark was MP. My bad. I skipped it. We did mark MP congruent to MP. We said reflexive property, but we didn't show it. So from there, now that you have your stuff marked correctly, and we already know what it was going to be, but it should be obvious to you, HL. Alright. Oh, what I want to say before we move on. Like, whatever you start out by, it could be given, or more than likely it's going to be given. If they start out by mentioning something in the proof, at some point you're going to have to give a reason based on that. Like on this proof, they started out by mentioning MP was perpendicular to LN. So in my mind, I know somewhere in my proof I'm going to have to mention that definition of perpendicular lines, just based off them mentioning that. In the last proof, they started out by saying YZ bisects an angle. I know at least one time in that proof I'm going to have to mention the definition of an angle bisector. Just because they told me something, an angle got bisected, I'm going to have to mention that. What's another one that we did?
It's a wrap.
Oh, that first one that we did. They said K was a midpoint of JN and LM. At some point in my proof, I'm going to have to mention definition of midpoint. Y'all seeing how this flows? Whatever they mention, you're going to have to say that again once you actually talk about those pieces. Alright, we're going to see what you're going to be able to do. You're going to still need my help, I know it, but it's